In section 5.5 day 1, it's called conditional probability. The start of it can be a little bit intimidating. It starts off by saying that conditional probability, there's a key definition called dependent events. Those are events whose outcomes affect one another. And then all of a sudden there's a formula for conditional probability. You guys will see it in the notes. It goes probability of some event is probability A multiplied by probability, and then it goes B slash A. And the little slash means on condition A has occurred. What we are going to do is start off with the first example, which is cards, because once you see it, everything that's above number 2 in the notes will make total sense. This is an easy thing, and this is why cards are so valuable in studying probability. Once they show you what the idea means, it's not hard to take it to another level. So here's a standard deck of cards, and then this is what we're going to do. What we are going to do is we're going to take 2 cards without replacement. So here's 1 card, and then here is, okay, a second card. Now notice I didn't put this one back in. Here's what we are going to do. We are going to figure out what is the probability that when I put 2 cards down, they are both diamonds, okay? And there's no replacement, and then we just want to know, well, what is the probability of this actually happening? Here is where don't let your mind wander to a scary place. To figure out this answer, you guys could have done this before this day. It's not hard. The probability of this event happening, you can put an E or diamonds if you want, is equal to, now you go to your first card. When I put this first card down, what is the probability it was a diamond? Well, there was 13 out of 52. And so then, what is the probability that this second card is also a diamond? Here's what we don't do. We don't freak out wondering, well, is this a diamond, is this not? We are doing theoretical probability, even though you're seeing an actual experiment. We just assume it. We just assume the first card's a diamond, and then we assume that this one is also a diamond. Well, what was the probability that was a diamond? How many diamonds are left? There's not 13. There's only 12. How many total cards were left in the deck? Well, there was only 51 because this one was already there. This is what conditional probability is. Okay, it's like saying, what is the probability of this happening? Event B is a second diamond. On condition A already happened. We don't even worry if this wasn't a diamond, this first card. The multiply should also make sense. We are going to pick 1 card and a second, and the word and does mean to multiply. And so again, cards are an amazing way to teach probability in its easiest sense, and then we can start to expand on it. So number 3, many of you in today's world might scoff and go, this is an unrealistic problem. This is for 20 years ago, but I have a prime example of it where this still does happen. So 90% of adult Canadians have a cell phone. You might be wondering, what? Isn't that 100%? No, some adults are still standing by. They don't want a cell phone. There's a few. And then think of very, very old. There's probably 80, 90, 95-year-olds who have no need for a cell phone. So not every adult Canadian does have a cell phone. Now, out of the cell phones, here's another one where you might scoff. So 90% have cell phones, 70% have a smartphone. That might not be totally correct in these day and ages, but there are phones that are not smartphones. There's phones that are advertised for senior citizens, very large buttons, and they're not a smartphone. All they do is just call. That's all some seniors want as an emergency plan if they're driving somewhere. So then here's how it goes. Imagine you're walking down the street and you want to say, what is the probability that the next person you meet has a smartphone? You might be like, well, it's 70%. Well, no, it's not. Okay. The probability of this event that the next person you meet, if you say, hey, do you have a smartphone, is not 70. It's 70% on condition that that person has a phone at all. If they don't have a phone, well, then all bets are off. So then here is how it actually goes. We're just going to convert to a decimal because decimals are easier to work with. 90% is just 0.9 as a decimal. 70%, okay, so that's as a decimal again. And here's what it is. If we just go back to the formula, the 70% is the probability that the person has a smartphone. The 90 is the on condition they have a phone at all. And so when you multiply these values out to get a 0.63 and then convert it into a percent, 63%, what you see is it's not as easy as at first appeared. If you just put this question in front of a common person who doesn't know statistics or probability, they probably would be 70% or very confused. But this is what the conditional probability formula does. Now, this would be like an entry level problem that really does a good job explaining it. This moves it to a higher level. What would be by far the highest level? And we'll go to football. Hopefully we do get a football season this year. In the question, we talked about the riders. So that's why I picked my riders card. And I'm going to put the cards away because that's not the idea. For the final example of the day, in number 4, it says the riders have a 60% chance of winning when the stadium is sold out, a 40% chance of winning when it is not sold out. And then they say the very next game, which would be the home opener, hopefully a game that's coming sometime in a couple of months, it'd say the chance of a sellout for the Riders is 30%. What are the chances of the Riders winning the next game? Again, to somebody who doesn't know stats, they might be like 60%. But no, there's a whole lot of things that are going on to figure out the probability of this event. Now, again, this is the highest level of conditional probability, so don't panic when you're wondering if you could have done this without any influence from me. We need to see this kind of in a workable manner a first time. So here's how you'd begin. What we would first of all take a look at is what is the probability of them winning when the stadium is sold out? Well, here's how it goes. Okay, the probability of the Riders winning is 60% or 0.6 on condition it is sold out. Well, the probability of a sellout is 0.3. Here's your conditional probability. The probability of winning on condition the sellout has already happened. But then here's why this one is such a high-end problem. There's an or, and the word or means an add. Okay? What's happening is the or is, well, they have a 40% chance of winning when it's not sold out. So let me do this one left to right. What is the probability of the stadium not being sold out? 70. If 30% chance of a sellout is going to happen, well, then there's 70% chance of it not selling out. What is the probability of them winning on condition that it hasn't been sold out? It's a 0.4. So here would be what the total probability is. This is a 0.18 or 18%. Multiplying right here is 0.28 or 28%. And your total chance would be when you add these together. So this is like high in probability. Again, I just want to repeat, since we're getting close to being done, probability, I often say it like an old movie. It's the best of times and the worst of times. There's some very, very easy probability ideas where you're like, oh, I could teach somebody who's 10 years old this idea. But then it can also really be something that pushes your brain. So don't panic. We're just trying to gain some experience.